The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Just to say that we will start the webinar in about 5 minutes. Okay, so I think we can start with this webinar about both the hope and the hype around blockchain. I see from the list of current attendees quite a few Italian names, so this just reminds me to mention with you guys that you are very welcome to ask and type your questions in Italian as well. I will, if I have time to take your questions, I will anyway translate and reply in English. I also see my friend Nihil in the list of attendees. Hi Nihil, it's a pleasure to have you here around, even though only virtually. Okay, so the hope and the hype of blockchain. What is the expected takeaway from this presentation? At the moment, at this time, personally, I'm highly focused on problems that affect a particular industry. In my specific situation, the industry is the energy industry, and there are structural, I would even say infrastructural problems in the energy space, and the situation is not particularly different in other crucial area of the world general economy. So blockchain is sometimes perceived as a sort of panacea, as a sort of magical device or tool that can be implemented or adopted or paid for and magically solve problems that otherwise would be very, very tough to address. Currently, I'm in the stage in which I'm curious, very curious about blockchain, and I'm just trying to figure out in which way I can possibly leverage the power of this thing, because I'm still researching the right way to call it, whether a technology, a paradigm, a database, this or that, and the new internet. There are so many different expressions to describe and define the blockchain that we are still researching the most appropriate one behind the hype and behind the hope to having found a magical tool. So the perspective is just going through the tools, concrete tools we have today to figure out whether blockchain can be helpful in our own domains and to solve our own problems. My name is Dino Esposito. You find on the slide my Twitter and LinkedIn accounts. At the moment, I'm the corporate digital strategist at Box Energy. Box Energy is a software house that is deeply involved in the development of software for energy utilities, with a particular focus to renewable the renewable energy business of electric utility. Well, to start, I think that nothing is best than a quote from a tragedy from William Shakespeare. A horse, my kingdom for a horse, a popular quote from the tragedy King Richard III. If we adopt this quote, we can easily adapt this quote to blockchain, and it becomes a block, my kingdom for a block in the chain. This seems to be the aura, the air, what we breathe, what we perceive out there. Everyone seems to be running into this virtual space where blockchain exists, and everyone screaming for a block, whatever, my kingdom, the entire kingdom, my business for a block in the chain. Blockchain has been the hottest buzzword of 2017, and even more it is hot in this first half of 2018. But if we look back, blockchain is a relatively new form of hype. Of course, blockchain has as a technology is about a decade old, but in some areas outside cryptocurrencies, which is the area where blockchain as a technology originated, the birth date of blockchain is really, really close to us. In particular, in energy, it was in the summer of 2016, so less than 2 years ago, when the very first documented attempt of operating a blockchain to exchange tokens of produced energy between users outside the power grid, the official, the regional, the national power grid was done. So less than 2 years ago, the first attempt, soon followed by larger mini grid at the end of 2016, and then in the course of the entire past year, there have been a lot of pilot projects from Enel and from other large utilities. So blockchain is the hottest buzzword of these times, and it's neither a technology nor a product. And really, I wonder how many people who, how many executives, how many managers, more than developers or software experts, are really aware of the fact that blockchain is not a technology, not a product. It's not something you can buy. It's not a service, or not yet a service you can buy, you can get a license for and start using. For the most part, blockchain is is a paradigm for storing data. And all this emphasis reminds me of the gold rush. The gold rush is something that happened in the last decade of the 19th century, primarily, or it started in the northeast of Canada, more or less in the same areas where the popular Scrooge McDuck got his first gold coin. The gold rush was something that was triggered by a guy, George Carmack, who found evidence of gold on the Bonanza River up in the Klondike, northeast of Canada. And the voice rumored out of the police office where he claimed passes and the right to dig out the territory. And a lot of people, was calculated over 100,000 people moved up in the north on the wings of the enthusiasm of getting rich. And a similar rush, virtual rush, seems to be occurring towards the territories of blockchain. The trigger is possibly the same. And what is the trigger? Money, in first place. Money, possibly not necessarily in the terms of the bills in our pocket, but money in the sense of more revenues for companies or less costs for companies. Success. Where there is money, there is also success. It's part of the human nature. Stability for the business, and in particular, stability for the IT, the information technology, information departments. Stability for the infrastructure that could allow companies to do business more and more effectively. In the gold rush, there was also the dream of changing the quality of life. For blockchain, there is also a segment that has to do with the dream of living in a world that is decentralized, that is apparently more democratic, in which there are no authorities, whatever form, to be trusted, but in which people participate directly to their own lives. Whatever is also a term in red on this slide to indicate that blockchain sometimes seems just to be the magic tool that can give us any of the previous money, success, stability, a better life, whatever, but quickly. And this kind of things are not usually realistic to have. But let's find out more. Bitcoin. Why Bitcoin is relevant here? Because Bitcoin is the cryptocurrency, the first cryptocurrency to become so popular. And blockchain is the name of the underlying storage technology used for the Bitcoin platform. So Bitcoin and blockchain are distinct things, but they are tightly related. Blockchain is the underlying storage technology for the Bitcoin platform. And Bitcoin has a cryptocurrency created an aura of magnetic mystery around it. Oh, with Bitcoin, you can get and send out money in an anonymous way, possibly without being recognized, without anybody in the bank, your significant other, your boss, checking that, having the right to look into your own things. So there is a sort of a private, really private space where nobody is allowed to get into. And this is the aura of mystery around Bitcoin, and blockchain inherited a lot of this magnetic mystery aura because it's technology behind Bitcoin. Today, the use of blockchain is advocated in many different business domains, in the finance, so well beyond the cryptocurrency space, so in general finance, for monetary transactions, in healthcare, in the supply chain industry, for identity management. There are projects or just dreams to use blockchain to create a sort of global, worldwide database of personal identities. And when it comes to this, also education is possibly a good target for blockchain, because in education, we could possibly end up creating a global, worldwide shared database of personal education records, so that there will be no longer the need of proving and verifying academic titles or just the education when you apply for a new job. And energy, last but not least, is another industry where there is a lot of attention to whatever we can achieve out of the blockchain technology. What is blockchain exactly? At the end of the day, if we look at the real set of things, the real mechanics of it, it's a linked list of blocks. And if you are a software expert, if you are a developer, you know very well what is a linked list. It's a structure, a data structure that existed since the early days of software programming. So it's nothing new. So just the fact that blockchain is a linked list of blocks per se is not significant. The significance of blockchain has other reasons. What is a block? A block is a group of ordered transactions. Yes, but what is a transaction then? A transaction in this context is a collection of information. But I played in this slide to use the 4 adjectives: atomic, consistent, integer, and durable, that has developers we typically associate with the idea of a database transaction. We are talking about the same thing. And if we compare the idea of a linked list, the idea of a block, and the idea of a transaction to concepts we probably know very well from the space of databases, we find that the linked list overall is the database, the block is the table, the transaction is the record being written. And we want that any information we write transactionally results in an atomic operation, a consistent operation that nobody can alter, so integrity of data, and durable, that persists forever. There is, however, a crucial difference between the traditional database and the blockchain, the fact that we cannot alter or not easily alter whatever has been written. So the meaning of durability, an attribute typical of transactions, is that the durability is hard to change. Not impossible, just hard, algorithmically hard to change, because the idea behind blockchain is that if something is updated, there should be a good reason, there should be consensus from the participants, members of this network to make those changes. In the end, if I have to summarize a description, quick description for what a blockchain is, I would say it's a new type of a database. Immutable, append only, and distributed. Now, if you are a software architect or software developer, you may have heard about a pattern for application architecture that is called event sourcing. Event sourcing pushes the idea of using another new type of a database, very close for some aspects to what blockchain is. An event sourcing database, an event database is immutable in the sense that what is written is written. An event is, in that context, a memory of something that has happened and that has been recorded. Append only, you can only keep on writing. And updates are just new events appended to the list. Distributed, because in the case of event sourcing, the database must be replicated or sharded. In case of blockchain, it is immutable, it is append only, it is replicated, not sharded. Blockchain originated, as I think I said already, with Bitcoin. So it was the infrastructure that allowed Bitcoin to work. Now, it is good to spend just a few seconds thinking back to Bitcoin. Bitcoin has not been the first attempt in history to create a peer-to-peer online payment systems, private payment system. It has been, however, the first of many created over the years to brilliantly solve the problem of double spending. That's the issue, because physical money is easy to understand. For physical money, metal coins or paper bills, those are clearly something physical, material, that can only have one owner. If I have the bill, you don't have the same bill. With digital money, we are talking about files, and files are so easy to duplicate. Someone can argue that even money can be not so easy, but can be duplicated, but that's a crime. So the problem of arranging, setting up an online payment system, alternative online payment, peer-to-peer payment system, was just how to solve the problem of ensuring that no item of digital money could be double spent. The Bitcoin creators, the Bitcoin owners, solved this problem by creating a database of monetary transactions with certain characteristics, and those characteristics which make the blockchain such a particular kind of database essentially made algorithmically extremely problematic, close to be impossible to double spend the same digital money. The idea of Bitcoin and blockchain together has been multiplied across a number of other cryptocurrencies. There are so many cryptocurrencies today, and offering coins of this new cryptocurrencies is also, has been, at least in the past few months, in the course of the past year at least, has been an easy way to raise a good amount of money. So cryptocurrencies is an entire new universe that descends from Bitcoin and is based on a storage mechanism that follows the same paradigm of the Bitcoin's blockchain. And again, the reason why in the space of cryptocurrencies we do need a storage mechanism with the characteristics of the blockchain, that is necessary because there is the strict need in payment to solve the problem of avoiding double spending of the same digital money. And then, why not everything else? Why not? This is the dream, or this is the challenge, or this is even the opportunity. Why not everything else? Why not taking blockchain and making it bigger, larger, to encompass alternative, different scenarios, business scenarios and business domains? In the end, this is the common thought. We are talking about a database that is decentralized, that doesn't require a central authority, doesn't require a single point of failure, doesn't require trust into a single entity, and possibly doesn't even have to pay the costs of passing through those bottlenecks, those single point of failure. There are so many articles out there, and it's really hard to figure out where truth begins and when the gray area of borderlines end, about the fact that with alternative payment systems based on blockchain technology, the cost of transactions to send money would be essentially dropped very close to zero, talking about 10 times small. I don't know if, honestly, if this idea of micropayments with essentially no or very low, very basic transaction fees is really realistic. At the moment, it doesn't seem that much to me, but this is possible because I'm still in a phase of my understanding of blockchain that sounds close to skepticism. Anyway, this is the curve growing. It started with Bitcoin, it expanded to cryptocurrencies, and now the question is it sensible? Does it make sense to expand blockchain to nearly everything else, from energy to supply chain to healthcare to education to identity management to property management and so forth? We'll see. Blockchain facts. As I said, it was created to solve specific Bitcoin's problems, and it resulted in a decentralized storage for outcomes of financial transactions. The problem was avoid the double spending of digital money, and at the end, having solved storage and double spending problems, it became a clear breakthrough, but for the cryptocurrency space. Information about all of the transactions are replicated on all nodes of the network. And by the way, the need of decentralizing storage is tightly coupled with the need of solving the double spending problem. Those two things are tightly related, and it couldn't be different. Because without a decentralized storage, we would have a single centralized storage, a single centralized database that someone has to take care of. And we are back to square one. Okay, we don't want to trust as far as financial transactions are involved. We don't want to trust SWIFT, the worldwide organizations that banks talk to whenever there is a transaction that involves two of them. So whenever you transfer your money from your bank account to another bank account, you give your bank an order to transfer money, and the bank publishes a transaction to the SWIFT system, which will verify that your bank account exists and has the money, that the target bank account exists and can be reached, and it ensures that transactionally the money is removed from your bank account and the same amount of money is added to the target bank account. We are talking about doing these operations in a different context in which there is no such a single central authority by design. This is the point. So if we don't want to have by design a single database, we need to have many different databases, copies of each other. So information about the transactions must be replicated on all nodes of the network, and all nodes of the network maintain full history of assets, of money, transactions, and users in the node. So there is a huge database of all history of transactions copied on all nodes that gains access to the network. Gaining access to the network is easy. Just ask, just do it. Just install some software on your computer, connect to the network, connect to a specific website, and you're there. And once you're there, you get your own personal local copy of the entire Bitcoin's blockchain, which is a huge amount of information that is replicated, that has to be downloaded. And by the way, downloading data from a web server costs. You probably don't much have the sense of the electricity being burned to downloading data. But just let me give you a very quick idea of the amount of energy that could be involved in huge downloads. You know probably the Esposito song. As of March, so a couple of months ago, it counted on YouTube over 5 billion downloads. Now, to download 1 megabyte of information end to end, so including the costs of the energy involved in the travel of in the movement of the information from server down to your computer, including the energy for your computer, including the energy consumed by the servers, there is a sort of generally estimated cost of about 6 watt of energy per megabyte. Now, if you take the size of the Esposito video, if you take the amount per megabyte, if you take the number of 5 billion downloads, you get an incredible amount of energy that has that is the same as the energy that in an entire year, a region of 500,000 people in Italy, so in one of the 10 largest economies in the world, would consume. The same as the energy consumed in the course of a year by 500,000 people is the energy consumed to play Esposito 5 billion times. So there is a lot of energy involved in downloading of incredible amounts of data. And this kind of a download is mandatory, necessary in the blockchain space. And there is more. Downloading on local nodes is necessary because all nodes must vote in a way to approve every single transaction that is ever published to the blockchain. So for every of the, I don't know, thousands, millions, billions of financial transactions, through Bitcoin must be approved by voting members of the network called miners. This is energy that is burned. But even beyond the point of energy, there is the need of decentralizing in order to have a general approval about a transaction that essentially would validate and guarantee consistencies and integrity of every transaction, avoiding double spending of digital money. So in the end, in a Bitcoin kind of database, update operations are subject to consensus, must be subject to consensus, and this is necessary to ensure that transactions are synced up across the network. Decentralization is then the magic word. No single point of failure, no single authority to trust, immutable, true forever status of facts. But it is not free. It is possible, but it's not free. And it's not free in terms of costs, physical costs of energy and space, storage, and it's not free in the sense of developing. Issues of decentralization, beyond energy and beyond those things. What if the database gets corrupted? If you ever worked in your software environments, if you ever worked with event sourcing, this is an issue. I teach often courses on event sourcing and CQRS, two software architectural patterns. And one of the questions I receive each and every time I teach these classes is, what if the event store database gets in some way corrupted? That's it, you're gone, it's gone. Because you can, if you have a backup, it's fine. You can restore the backup, but the backup restores a situation that is of a few moments, minutes, days, weeks before. You lose everything in the middle. And look, when we talk about event sourcing, we talk about the very basic events that take place in the context of the application. You lose, you cancel a segment of events happened in the context of the application. Not that database corruption is not an issue in regular databases, but at least in environments like SQL Server, Oracle, SAP, IBM DB2, and whatever, we have decades of experience, and we have technologies that are mature, and we have people, experts, DBA, IT experts that know how to possibly deal with those kind of disasters. If we go with blockchain, we are open to receive, to face development issues, and development code written to implement the blockchain. And again, every application needs to have its blockchain. Development must be right the first time, so development is slow. Also because if something is found broken in the implementation of the blockchain, of the storage layer, and you need something, you know, and there's a fix to apply. Applying that fix, modifying the database requires consensus or requires a fork, a hard fork. So, okay, we discontinue this blockchain, we create another blockchain. So also the problem of backward compatibility becomes a serious issue to take into account. Problem number 2. Validation is a need. There's a strict need for validation. So any transaction, everything being written must be certified, not by a single individual, single authority, but by the majority of actors, of voting members of the network. Why you should apply to be a voting member of this network? You should be paid for that or rewarded in some way for that. In Bitcoin, miners get a fee for every transaction, they are the first to approve. But the incentive system for any blockchain solution you want to arrange has to be devised from the ground up. It's tough to design because it has to balance the amount of the reward with the credibility for the data in the system you gain out of approval. Because an incentive system that is dummy, that says, okay, you are there, you just because you're there, you can approve. Well, that means that the data possibly being stored and certified and validated and written forever, hard to change, is stupid information, is frivolous information. So rewarding and credibility of the stored result must go hand in hand, and then in general an incentive system is very tough to design, and Bitcoin is a great exercise in this regard. Data must be consistent and coherent. And then third problem of decentralized databases, the costs of operations, because there are thousands of blockchain databases that must be kept in sync, and that involves a huge amount of data to be transferred. So centralized versus decentralized. Consistency and reliability of data are, needless to say, so much easier and cheaper to achieve in a centralized system. Also, the control of users is much easier in a centralized system. In a centralized system, you are the administrator, the owner of the system, can decide who gets in, who gets out. And the misbehaving users can simply be cut off and blocked from accessing the system. This is not, by design, the point of a decentralized system. Or rather, it is not what happens in Bitcoin by design. But in a custom blockchain system, the problem of how can I control users and how can I defend myself from misbehaving users is an issue to be faced. And the more you try to solve these two issues, the cost of consistency and reliability and the control over users, the more you take these two issues seriously, the more you move away from the pure idea of a decentralized kind of people managed system, democratic system. In a decentralized space, backward compatibility, at least in certain cases, must be certainty. And then there are the costs of scalability. The same data must be kept in hundreds of thousands of places instead of being saved in just one place. Transmission, verification, storage, overhead. We are talking about, in other words, talking about applying the parameters of vertical scalability to a distributed, horizontally distributed system, which means multiplying the cost of vertical scalability by the number of horizontally distributed copies of the system. And we are talking about essentially this. We have a system and we make it bigger, and this is the standard approach to vertical scalability. We are talking instead in blockchain in a network that must be scaled to a bigger network. And we have just the costs multiplied by the number, thousands typically, of nodes. The wizard with the magician taking the rabbit out of the cylinder. Blockchain is what? Panacea for sure. Oh, that is what most people seem to think. Panacea for what? For many aspects of the industry like healthcare or supply chain, or perhaps finance, or even more energy. For all these industries, blockchain seems to be panacea. Why? I wonder why. And my answer is that in all these industries, and possibly more industries, there is a common factor. And the factor is long overdue IT upgrades. So in all these industries, for many years, for decades, 3, even 4 decades, 30, 40 years, there has been no significant updates of systems. So now, the supply chain, in the healthcare, in finance, even in energy, companies face, for maybe different reasons, face the need of more modern systems. And all they find is old infrastructure, old code that dates back to decades ago, old technologies, old architectures, old hardware, and a variety of systems, legacy systems that possibly talk to each other, possibly manage to perform transactions and push ahead the business, but old, long overdue IT upgrades. So in all this industry, there is the need, the perceived need of changing and renewing things, but everyone realizes that it's going to be hard, very hard, and very expensive. And if a CTO, a CIO goes to a CEO and asks for a lot of money to renew the IT, he is possibly going to get a refuse or to have a hard time unless it is able to sell the promise of a wonderful new world resulting from spending all that crazy amount of money. So blockchain, it seems to me, to appear, to be presented, to be perceived, or to be dreamt of as an attempt to sugarcoat the real IT bill. It will cost us a lot of money to refresh, renew, upgrade our IT infrastructure, but with blockchain, instead of classic canonical storage and architecture technology, it's not that fun. I mean, blockchain makes it cooler in a way. Now, in my opinion, and again, this is just my humble personal opinion, blockchain, for the most part, doesn't fit the use cases it is primarily pushed for. The industry, all the industry these days needs primarily freedom of change, flexibility of solutions, flexibility also to expand dimension of systems, features in systems to size new and more appealing business opportunities. Blockchain instead is pretty much static when it comes to storage. So I wonder if in blockchain beyond the hype, if in blockchain beyond the hype there is a really hope to be able to achieve what we dream of. So my answer, my final point is blockchain is not a breakthrough. Blockchain instead is a new storage paradigm. It's not something you can download. It's not something you can install. It's something you develop, learning and applying a new storage paradigm. Applications you write will work on top of this new and completely rebuilt storage paradigm. It's not the same as using the new version of a database. It's not the same as using a NoSQL database instead of a classic relational database. It's about using a database that doesn't exist, a database that you create using possibly canonical databases to store information, but with an API on top of that, that ensures immutability, consensus, votes of members, cryptography, and many other features. So applications that end up using or plan to use blockchain, at least building from the ground up a solution, are likely to face a lot of inefficiency and costs when compared to the same level of efficiency and effectiveness of industry products than going with the centralized form of storage. When we mention breakthrough, the concept of a breakthrough, what is a breakthrough? Blockchain is often compared, the advent of blockchain is often compared to what it was the advent of the internet some 20 years ago, but it's different. It's different because internet made it possible things like e-commerce that weren't possible before. Blockchain made it possible cryptocurrencies. But in my opinion, I cannot see, I'm not able to see in which way, beyond dreams, hypes, blockchain can really enable use cases, features, and functions that aren't possible in a centralized storage approach. This said, what if I still want to use blockchain? There are a few big players. The Chinese Google, Baidu, through Baidu Trust, Oracle, IBM, Microsoft, SAP. These are giants, major software majors that have or plan to have their own blockchain services available, blockchain as a service. And today, if we want to practice, so beyond the theory of this webinar. So at the end of this webinar, if you want to take that blockchain to the next level, what can you realistically do? Choose one of those providers and choose any of those three generic blockchain ready-to-use platforms. I said many times, blockchain is not something you can download and install. That's true. But through the services of Microsoft, IBM, and whatever, you can have access as a service to a number of existing blockchain-based infrastructures. So all you do is coding, programming against the APIs exposed by blockchain as a service, and you end up using at the lower level any of those blockchains. Of course, those blue balls, Hyperledger Fabric, Corda, Ethereum, all those can also be taken, they exist as open source projects. So you can take that code, you can recompile the code, you can host the code, and you can run your own blockchain from scratch without rewriting everything from scratch but the application. So you can go directly with the blue bubbles, or you can go through the services of cloud providers. Hyperledger Fabric is an extremely modular and extendable generic blockchain platform. It is built around 4 core functionalities. It's a distributed ledger, so it's a ledger of business events. Distributed. Well, distributed actually means replicated. It has a module for consensus, so that each transaction recorded in the ledger is approved by voting members. Membership to decide who is in and who is out. And then what is really stored, which makes Hyperledger Fabric a generic blockchain platform, is the concept of a smart contract. A smart contract is essentially a piece of software that describes a generic contract between two parties. So it's a smart contract is a sort of an object expressed in a programming language that has a function to approve and a function to execute. So there is a preliminary check that returns a Boolean value, true, false. This operation is approved, makes sense in the overall business domain, and then do it. Hyperledger Fabric is offered as a permissioned and private blockchain, which means that Hyperledger Fabric is not like Bitcoin, is not an open network, but access to the platform is restricted to members. And who decides how to get member? Who decides the rules? Owners, runners of this permissioned and private blockchain. So it's a private network in the end. It's again, it's a company or a consortium of companies that create a sort of a website, and you become the user of that website. And then the website is operated according to the storage paradigm of blockchain, which is a bit different. But in the end, you are trusting someone. So Hyperledger Fabric is not for an open network globally available. Consensus is reached at the transaction level, and only the parties involved in the transaction have to vote. So this is a sort of revolution compared to Bitcoin and the common idea of blockchain. So there is no public voting being made on transactions, but only the two parties that share the smart contract have to agree. Only their two parties have to agree, okay, this is good, this is great, this is okay. And at that point, the transaction that those two parties have mutually approved is stored and made available to anybody. So it's something closer to the real world of business, and Hyperledger Fabric is definitely something to look into for some serious blockchain development in some industries. For example, education, for example, identity, for example, property of goods like land. Smart contracts for Hyperledger Fabric can be written in Go and Java languages, and the owner, the maintainer of this network based on the blockchain idea is the Linux Foundation. Corda is a specialized distributed ledger for the financial industry. So it's dedicated to financial transactions. It has the explicit purpose of recording business agreements among registered financial institutions. So Corda is a sort of blockchain network of banks or financial institutions. Permission and private, of course. Consensus at the transaction level only between involved parties. Smart contracts written in Kotlin and Java, and different with Hyperledger Fabric, contracts in addition to the raw data are smarter, and they can also contain legal prose, so just the text of a contract. So contracts in Corda are closer to contracts in paper we may know from our understanding of the world, maintained by a private company called R3. Ethereum is closer to Bitcoin, and Ethereum historically has been the first post-Bitcoin example of blockchain. It's a decentralized platforms to run smart contracts. Generic, any sort of smart contract, so no specialization of contracts. Generic blockchain platform, permission, but also permissionless, like Bitcoin, so open to anybody. Consensus is not between the two parties involved, but because it could be permissionless, so open to anybody, then Ethereum requires proof of work, which is an approach very similar to Bitcoin. All participants have to agree upon a common ledger. So once a transaction involving a smart contract has been recorded, all participants, all voting members of the network must agree on what is the new state of the shared ledger, the shared database, and this database is shared and everyone sees everything, which is not what happens in Corda and Hyperledger. Smart contracts in Ethereum for the Ethereum platform are written in a programming language called a sort of JavaScript called Solidity, maintained not by a single authority or a company, but community of developers. Now, to finish off, let's talk about energy. Using blockchain in the energy space means that we want to have a software engine that defines the blockchain storage and the blockchain voting and consensus algorithm for exchanging energy, because using blockchain in the energy space for the most part means stock exchange of energy tokens. The software is distributed in a network of nodes. A portion of the software will also monitor access to the power grid. Prosumers and consumers. A prosumer is an individual that is both a consumer and a producer of energy. Imagine of an individual that has a rooftop solar panels and consumes his own energy and sell the energy in excess. Both need to have an account to this blockchain marketplace application. Prosumers typically also will have an IoT device that monitors strictly what has been produced and receives signals from the marketplace to start and stop production depending on the price. Prosumers, the prosumer IoT device generates and sells tokens of virtual energy. So the energy that will be eventually produced. This aspect needs a little bit of further explanation. Usually the market of energy is the day before, happens the day before. So today I'm selling the energy that I will produce tomorrow. So this is the standard way that regulates the direct marketing of energy. So this is so that the tokens of energy to be produced means that will be produced according to forecasts the next day. Prosumers sell orders to the marketplace for the tokens of energy they plan to produce the next day, and consumers place buy orders to buy at the best possible price the tokens of energy they expect to be consuming the next day. And then the marketplace application matches orders and stores results in the form of a smart contract permanently. The database of the marketplace is then shared across the network, can be checked via the application. Only the consumer and the prosumer will validate the contract, and it's essentially to be determined what happens for the physical delivery, the way in which the physical delivery of the energy takes place, because energy is not something that can be downloaded. It needs to be delivered through a power grid. So graphically, the IoT device receives domestic consumption and domestic production and uploads information to the cloud, which is generically referring to the blockchain system. The application for this specific domain will also match information coming from connected IoT devices for prosumers, will match this information with production forecasts, weather forecasts, price forecasts, makes an algorithmic decision that decides, for example, the energy in excess, if it has to be monetized through the marketplace or just stored somewhere, for example, in a battery. The consumer will check via mobile app the state of things, and if the decision is to sell, then another app or another system, another blockchain-based system will take care of the physical trading of energy, or it could even be the traditional open regulated energy trading marketplace. Now the question is, for this system, do we really need a blockchain? So is blockchain the only way we have to implement a similar system? The answer is no. We can, a system like this is needed. It would be good to have it, but we don't strictly need blockchain for that. And if this statement, this final statement, seems to be a little bit too much, let me ask you a question. Have you ever used DocuSign? Do you know what DocuSign is? DocuSign is a system used by major. Personally, I've been using that through Microsoft and through a few other companies, non-Italian companies, worldwide companies all over the world, to sign contracts. DocuSign existed for 10 years. It could have been blockchain, but it's not. So this brings us back to the concept of breakthrough. E-commerce. Nobody did it until internet became a commodity. So internet was, for e-commerce, a breakthrough. Nobody did IoT until smart devices became affordable. And now the question is, someone will be doing blockchain when blockchain becomes affordable. But honestly, I don't know what could be a realistic use case, a real breakthrough for blockchain as a technology. Identity, health, education, properties, management of property are all scenarios where blockchain seems to be useful, but even not. One global digital identity owned by everyone, or medical records shared, or certificates shared, or property of land or intellectual properties are all possible scenarios where we can have blockchain applied, but also not. That's the point. And if it comes to, okay, should we use blockchain? What is the benefits? More costs for the most part. And blockchain and its costs become affordable and sensible the moment in which we don't have alternatives. The moment we have alternatives, why should we go with blockchain? This is essentially my point. No matter what the World Economic Forum seems to say, that with blockchain we will have a better world without corruption, without fraud, without costs of intermediation, with lower costs of financial operations, without the need of figuring identities, without jealousy, with more love and a safer world for everyone. These are just dreams. But if you want to read about those dreams, www.worldeconomicforum.org, communities, the future of blockchain, that is the link. In summary, most of the time, blockchain, in my opinion, is a solution waiting for a problem. And here is a nice video that I invite you to look. It's a 5 minutes video summarizing most of these thoughts. That's all. Thank you very much for your time. I will be around for a few more minutes if you may have questions. And if the whole theme of blockchain and crypto values is attractive to you, there is in Milan in mid-June a conference from Codemotion. So I invite you to take a note of that. Again, thank you for your time, and I will be here around for 5-10 more minutes waiting for your questions. Thank you. One question that I have is in regards to centralized versus decentralized. Is it true, or is it agreeable that decentralized provides more benefits in making it more difficult for monopolies to form? Yes and no. I mean, in my opinion, from a purely theoretical perspective, I would say yes. But the point is, are we sure that for the specific business we are considering the monopoly is an issue? And then what kind of monopoly? I think that if you think of blockchain as a permission blockchain, is a monopoly in the end. It's ultimately another type, maybe smaller, more controlled, but still a monopoly. Anyway, the question, the answer, in my opinion, is it depends on if having or running through a monopoly is an issue for the specific application. Another question is, it's from Antonio. Antonio Boy says, having a central authority that owns and manages the blockchain is the same as having a centralized scenario. That's exactly my point. I'm tempted to say that is, at the end of the day, exactly or nearly the same. Yes. Is there an alternative from Maxim? Another question. Is there an alternative to blockchain? If we talk about the digital currency, I don't think so, or at least, the blockchain way of storing data makes sense for digital currency, because with digital currency we have the problem of avoiding double spending. Now, in history, if you, this is easy to verify if you go on Wikipedia or running a few quick queries on Google. Bitcoin guys, the Bitcoin people have been the first to solve effectively the problem of double spending. They have not been the first to try to build a digital money system, but they have been the first to make it work. So, is there an alternative to blockchain for digital currency? I would say no, not known at this time at least. So another question from, again, Antonio. The only blockchain that makes sense is Bitcoin. I would say today, the digital currency space is, in my opinion, the only scenario, the only business domain where a blockchain storage makes really sense. In that context, blockchain is a breakthrough. Slides will be available through the website. Also, the recording of the webinar will be available through the same link. One more question from Nader, as I see. Yeah, I mean, the question is about the blockchain dev community working on alternative consensus methods that may require less energy. Of course, this is exactly the case with Ethereum. And there might be others. So yes, the cost of energy might not be an issue if we look into alternatives, possibly Ethereum-based or Ethereum-inspired blockchains. So yes, definitely there are, or people are actively researching ways to have a consensus in the context of a permissionless network. Different consensus methods are being researched. One more question about Lightning networks. Essentially, a Lightning network is Lightning.network for more Lightning network for more information. This seems to be an interesting, interesting because of the promises. We have to see if it really works and if it really scales. Seems to be a platform inspired by Bitcoin and blockchains to run instant payments with essentially nearly zero costs. Now, it's been, it's the cutting edge. It's cutting edge of technology. Some people seem to believe that this could be And again, this is a nice story. We are all researching what could be the next killer app that promotes blockchain and to the rank of a breakthrough. And in many cases, in many scenarios, this has been porn in the past. So some people believe that porn could be, and micropayments for viewing porn could be possibly, joke or not, you'll say, you'll decide about that, could be the future. Yes, Lightning networks are for instant micropayments, are something being experimented, but again, we are in the realm of monetary transactions again. So energy, education, healthcare, supply chain, I'm not sure and keep on not being sure that it will be space for blockchain. Okay, that's it. I'm going to terminate this webinar. Recording and slides will be available through the same Codemotion website. Thank you for attending.